Welcome back. In this set of examples, we're going to use log properties to simplify each of the expressions. So the first question here, or the first thing that we're asked to simplify, log of 6x minus log of 2x. So if there's no base showing, it means log base 10, but as we'll see, the base itself doesn't matter. To simplify, I'm going to use a log rule that says, I'll write the rule beside it. This is log of m minus log of n is log of m divided by n. So this is going to be the log of 6x over 2x. The x's cancel, and then 6 over 2 is 3, so we get just log of 3. That's it. Log of 3, that's our answer. We leave it as log 3. We can't do anything with it. We don't want to introduce decimal representations of log 3. We leave it as log 3. Next one, 2 times log of the square root of 11. Like, what can we simplify there? Well, I'm going to switch colors so it's easier to see what's going on. I'm going to use a log property that says I can bring a power down, but before I do that, I have to represent the square root as 1/2 power. And then the log property, I'll write that log property down. It is log of m to the power of n is equal to n times the log of m. So I can take a power that's inside the argument, or applied to the argument of the log function, the thing being plugged in. I can take that power and bring it down in front. So that 1/2 will be brought in front. I'll get 2 times 1/2 times log of 11, which is just log of 11 as a final answer. And I'll start circling these final answers because it's going to get messy. Okay, next, what do we do here? There's actually 2 different strategies that we could use. We could use a log property that says the log of m plus the log of n is a log of m times n, and multiply them together, or we can use a subtraction property, and I'm going to use a subtraction property. Actually, no, I lied. I'm going to use the multiplication property because we haven't used it yet. So this is equal to the log of 2 over 9 multiplied by 9. So the property, just to state it somewhere on the slide, is log of m plus log of n is the log of m times n. So the arguments multiply together. We get 9 over 9 canceling. We just get log 2. Okay, log base 16 of 1. That's 0. So the rule I use there is log of 1 is 0. Just memorize that with words. The log of 1 is always 0 because anything to the power of 0 is equal to 1. Log base 99 of 99. That's just equal to 1. Okay, and that's it. Log base b log base b of b equals 1. It's one of the log rules. Okay, next one, x's and y's. Don't be afraid of x's and y's. We're going to use that log property that says log of something minus log of something else is a log of the division. Log of xy divided by y, which is log of x. The y's cancel. Next one, now we're mixing in some cancellation law. Or actually, yeah, I'll do it this way. I will rewrite this one because it's the first time we've seen this. Ln means log base e, so I'm going to rewrite this as log base e of e to the 3x plus y. Yes, we can use the cancellation law, but I'm going to use another property instead. And then make a note that the cancellation law could be used. We're using log of m to the n is equal to n times the log of m. So we get 3x plus y times log base e of e, which is 3x plus y times 1, which is just 3x plus y. So that was probably confusing. And what's most confusing is that we didn't use the cancellation law. So I'll just say we could have used the cancellation law instead. Okay, the next one, I'm going to use a log property that says log of the top minus log of the bottom. If you have a log of top divided by bottom, you can write it as log of the top minus log of the bottom. So log of the top minus the log of the bottom. Log of 1 is 0. Oh, I got to put ln, sorry. So this is ln of 1 minus the ln of e cubed. So 0 minus the ln of 2e cubed, which I can write as ln of 2 plus ln of e to the power 3. Which is negative ln 2 plus 3 times the ln of e, which is negative ln 2. Oh, it should be minus. Minus applies to both pieces. Minus 3 times 1. So negative ln 2 minus 3 would be the answer. So natural question to ask is, why is ln of e equal to 1? And the answer to that is because ln means log base e. So this is log base e of e equals 1, since the bases are the same. Okay, then the next one under that, we have ln of the top minus ln of the bottom, so ln of ex minus ln y. So you got to be very careful with exponents. I'm going to draw some borders here to distinguish one question from the next. Okay, so you gotta be careful to distinguish what things are multiplied and which things are in a power. So if it's in a power, it's going to be a smaller font. This x is not in a power, it's e multiplied by x. Okay, so I'll keep going. This is the ln of two things multiplied together, so it's the ln of the first plus the ln of the second. We saw up above, top right, that ln of e is 1, since ln means log base e. So we get 1 plus the ln of x minus the ln of y. So in each of these, I'll say it's simplify or expand, depending on what you have. On a test, you'd be told explicitly it would say simplify or it would say expand, because I would say, you know, going from ln of ex over y to what we have at the bottom there, I'd say that that's not simplifying it, that's unsimplifying it, that's expanding it. Okay, and the last one, ln of 2 plus e, nothing can be done. It is not ln 2 plus ln e. You cannot do that. Ln of a plus b is not ln of a plus ln of b. It's one of the most common mistakes to use with log functions. Okay, some tough, really tough ones for manipulating log expressions. We're going to expand. And actually the second instruction should be expand as well. They should both say expand, because I'd say expanding is the opposite of simplifying. Log base 7 of x to the 5 times y to the 9. So the first thing I'm going to do is I'm going to write this as the log of the first plus the log of the second. So log y to the power 9. Log base 7, sorry, I forgot the log base 7. Log base 7 x to the 5 plus log base 7 of y to the 9. Then I might as well write down that rule since there's space to do that here. So log of m times n is equal to log of m plus log of n. Then in the next step, we'll use this property, log of m to the power of n is n times the log of m. So 5 times log base 7 of x plus 9 times log base 7 of y. So what are we doing right now? Why are we doing these things? Why are we manipulating these expressions? This is just practice. This is practice working with these log functions and these log rules. When my relatives come to visit from various parts of the world, I got family all over the world. From name a country, I probably have people living there that are related to me. They want to practice when they come to visit, they want to practice their English. So this is like practicing the log language. It's you practice it in safer types of environments like these ones before you practice using the log expressions in actual applications. So these are very artificial, they're compact, and they're tiny, and I don't say clear what you have to do, but it's well defined what you have to do. So it's a good place to practice the log operations. Okay, so the first rule I'm going to use here is the rule that says if you have the log of a top thing over a bottom thing, m over n, you can split that up as the log of the top minus the log of the bottom. So this becomes log base 8 of x to the 8 plus 1 minus log base 8 of 8 to the x. I'm going to use the cancellation law. I'm getting tired of bringing the x down and then saying that log base 8 of 8 is equal to 1. Like, we can do that, but the cancellation law really shouldn't be ignored. And whenever you can use it, you should use it. Why didn't I use the cancellation law on this piece? Like, I'm just going to say that what we have there is the answer at the end. I'm going to circle it. That's as far as we go. Why didn't I cancel the log base 8 and the x to the 8? Well, a few reasons. One of them is that the base of the exponential has to be the thing that matches the base of the log, and the base of the exponential is not an exponential. It's a polynomial. It's x. And the other is that even if it said log base 8 of 8 to the x plus 1, we couldn't cancel it still. We have to follow the rule exactly. Everything that's inside the argument has to be raised, has to be exponentiated to that power. Also, why didn't I bring the 8 down? That's another question. How come the 8 doesn't come down in front? And then that one deserves a little bit more writing. Note that log base b, I won't even write the base b because it's a distraction. It's not important. Log of m to the n plus k. I need more space to write this rule. Say log of m plus k to the n. I'll do that. Log of m plus k to the n is equal to n times the log of m plus k, but log of m to the n plus k does not equal n times the log of m plus k. And worse than that, so this is really going to bug you, log of m to the n plus k to the n is not equal to n times the log of m plus k. You cannot bring the k down there. You can't bring the n down there either. It's only in the first case where the entire argument of the log function is raised to that power, is raised to the power of n, that you can bring that power down in front. So you have to watch that. That's why we're not bringing the 8 down. So this is why we cannot bring it down. This is not x plus 1 all to the 8. Oh, I forgot I put this one. I thought I got rid of it. Okay, we'll do it. Yucky. We'll do it in several steps. First step, I was going to use two rules at once. We have the log of m times n is equal to log of m plus the log of n. We also have the log of m divided by n is equal to the log of m minus the log of n. And I'm going to make a new rule. I'm going to combine them. Combo rule. The log of m n over p. So you got two things multiplied on top, one thing on the bottom. What's going to happen? You're going to get log of m plus log of n minus log of p. So that's how you would combine those rules. So I'm going to do that. I'm going to say it's the ln, which is a type of log, ln of the first thing, ln of x to the power 3, plus the log of the second thing, ln of the square root of x squared plus 25, minus the ln of the bottom, ln of e to the x. Okay, there's a few things we can do. We can use a cancellation law here, since log base e of e to the x, cancellation law. Something else we can do is we can bring the 3 down in front, 3 ln x. And something else we can do is we can bring the 1/2 down in front, 1/2 times the ln of x squared plus 25, since square root's power 1/2, and the whole thing, the whole argument is raised to that power, so we can bring the power down. And that's it. That's as far as we can go. We cannot bring that 2 down inside that power. Since it is not x plus 25 all squared. If it was this, instead of x squared plus 25, then we could bring the power down. Oh, what am I saying? X plus 25 squared, or x plus 5 squared, etc. Bring the power down. And no, x plus 5 squared is not x squared plus 25. There's a cross term. There's a 10x in the middle that you get when you do your FOIL. All right, now we'll do the opposite. So we just looked at expanding expressions. Now we're going to bring them back together. Actually, that's a good spot to take a pause and start a new video.